All right, today we're going to look at ways that we can solve. So the first way we can solve is by finding a same base. So what that means when it looks, or when they're as exponents, the base is a 3. So these already have the same base. So if they have the same base and they're equal to each other, that means the exponents have to be equal to each other too. So to solve for x here, we just take 2x equals 3, divide both sides by 2, you get x equals 3/2. All right, number 2. Okay, so now we have a base of 2 and we have a base of 1. So we can either change this to a 1 or change this to a 2. The easiest way to do this one is change this to a 2. 2 to the power of what gives you 1? Well, that's just 0. So 1 and 2 to the power of 0 are the same thing. I'm just going to rewrite this side. Okay, well now we have the same base. We have a 2 and we have a 2. So that must mean the exponents are the same. So we can take 3m minus 1 equals 0. Add 1 to both sides, you get 3m equals 1. Divide both sides by 3, and you get m equals a third. Okay, looking at a couple more. Okay, this one, we have a 9 and we have a 3. So you could do this one, you could turn this into a 9 if you wanted, or we can change this one to a 3. I think this one is going to be easier to change to a 3 because 3 to the power of what gives you 9? Well, that's 2. So I could rewrite this 9 as 3 squared. And then that is to the power of negative 3. X equals 3 to the third. So now let's pretend I wanted to change this one to a 9. If I change this 3 to a 9, you would have to think to yourself, 9 to the power of what gives you 3? And that would be 1/2. So you could do it that way too if you wanted. Okay, so now we kind of have the same base. We have a 3 and we have a 3, but this 3 has a 2 on it, and it has this on the outside. So if you go back to your exponent properties from integrated 1, if you have a power to a power, you just multiply. So this is going to be 3 to the negative 6x equals 3 to the third. Okay, we have the same base. You set the exponents equal to each other, so negative 6x equals 3. Divide both sides by negative 6, and you get x equals negative 1/2. All right, moving over to this side. Okay, so here we have 1/9 and we have 27. Okay, so you can think 27 to the power of what gives you 1/9, or you can think 1/9 to the power of something gives you 27. I think both of those are really hard to think about. So you have a 9 and you have a 27. So we could change both of those to a base of 3. So 1/9 is the same as 3 to the power of negative 2 to the power of 2n equals 3 to the power of what gives you 27? That would be 3, and then to the power of n. Okay, so remember, power to a power, you multiply. So we have 3 to the negative 4n equals 3 to the power of 3n. Again, set those equal to one another. So negative 4n equals 3n. And anybody already know what this is going to be? So if I were to subtract 3n from both sides, you get negative 7n equals 0. Divide both sides by negative 7, you end up with n equals 0. Okay. Moving on to solving with the same base for logarithms. So when you have the same base for a logarithm, that would be this number down here. So if we look at this in purple first, so if you have log base b of m and you have log base b of n, okay, so you have log base b on both sides, that means that m and n have to be equal to one another. So if we look at number 5, we have log base 3, we have log base 3, so that means 4x must equal 2. Divide both sides by 4, and you get x equals a half. Okay, moving over to this one. Okay, so this one, you have to make it so it looks like this. So we're actually just going to add log base 4 of 5 to both sides. So we get log base 4 of x equals log base 4 of 5. And then we have the base of 4 on both sides. So that must mean that this equals this. So x equals 5. Okay, last one. Okay, I want you to think about this one for a couple seconds on how you can do it first before I show you. Okay, so if you have a fraction and it equals 1, if you have any fraction that equals 1, that means that that your numerator and your denominator have to be exactly the same. So if you had 4 over 4, that would be 1. If you have a million over a million, that equals 1. So that means these two things are the same. So we can take log, and if there's no number here, there's really just a 10, which we don't have to write. 5x equals log of 20. So these both have a base of 10. So we can set 5x equal to 20. So 5x equals 20. Divide both sides by 5, and you get x equals 4. All right, moving on. Okay, the next way we can solve is by switching from logarithm to exponential form. So right now this says log base 10 of x equals 3/4. Okay, well, there's not 2 logs, so you can't look for the same base. So when you're looking at it and you say, I have no idea, so this is saying 10 to the 3/4 equals x. Okay, well, what we just did was write it in exponential form without even knowing it. So if we write this in exponential form, it's 10 to the 3/4 equals x. And you type that into your calculator and you get your answer. Okay, same with over here. Okay, we have another 10 to the power of negative 2.2 equals x. Type it into your calculator and you're done. Okay, and then the last few problems we have, switching from exponential form to log form. So before you can do that, you have to make sure that your base and the exponent are alone on one side. So here's the base, which is 10, and here's the exponent, which is x. There's nothing else. There's no plus 5, there's no times 10, there's nothing else extra. So when we put this in log form, you're going to have log base 10 of 50 equals x, and you can put that into your calculator. Okay, then this one, okay, so this has an extra 5 with it. So to get rid of that, you need to divide both sides by 5. So you're really going to have 10 to the power of x plus 2 equals 0.25 divided by 5, which is 0.05. Okay, so we have our base, we have our exponent, and it's by itself. So we can rewrite this in log form. So we have log base 10 of 0.05 equals the exponent, which is x plus 2. Okay, so we need to solve for x. We still need to subtract 2. So log base 10 of 0.05 minus 2. Do not, whatever you do not combine these. That'll give you something completely different. So when you're typing this into your calculator, you'll want to put it in like this. So put these in parentheses and then subtract 2, and that will give you your answer. And that's all we've got.